Alright, American Railway Signals Principles and Practices, Chapter 15, Automatic Block System. Published in Signal Section AAR 30 Vesey Street, New York, New York. American Railway Signal Principle Practice, Chapter 15, Automatic Block Signal System. Copyright 1935, Auto Association, American Railroad Signal Section, printed in the United States of America. Our chapter 15, Automatic Block System. In the description and explanation of Operation Automatic Block System, given the chapter that to be understood with the circuit and special symbols within the wire nomenclature, not necessary specification or recommendation, practice signal section, Association American Railroad that indicated those of the non-use of the connection with the automatic block system described. The description is given within the thought that they will enable the student to more readily understand circuits in similar nature, the details of which, however, may be somewhat different depending on the practice of the individual railroad. Definition: the standard code of the Association of American Railroad defines the automatic block system as a series of the consecutive blocks governed by a block signal, cab signals, both actuated with the train and engine, certain of the conditions affecting the use of the block. It defines the fixed signal as a signal fixed for the location indicating a condition affecting the movement of the train or engine. Defines the block signal as a fixed signal of the entrance of the block of the governing trains for entering and using the block types. Automatic block signal system is generally designated with the signal track of the multiple track system. The signal to automatic block signal system is either overlap with the absolute positive permissive block schedule of the signal, with the track being signal at a train operation in both directions, with the multiple track system is usually signal for the train and operating in one direction. The congestion of the traffic could have with one of the more tracks or multiple tracks. Systems may be signaled for the train operation in both directions. Historically, the signals first used for the automatic block system were Hall enclosed disc type. This was in 1866 when they operated with a simple electrode magnet. In other orders stated with the following type that came into the use in clockwork, such as Gassett and Fisher were installed in 1879. Electro-pneumatic sophomore 1883, low voltage electro motor sophomore 1893, the electric gas sophomore in 1902, the color light 1906, position light 1915, color position light 1921. Prior to 1902, installation automatic block system were installed with the steam railroad, but it used the direct current track circuits. However, the track conditions of the electrically elevated railroads brought about consideration of visibility using the system of the operation with the railroads as direct current propulsion was used. The rail acting with the return circuit. The trouble was experienced with the using direct current track circuits in 1902. The first extensive trials with the alternating current and track circuits were made in California in 1906. The first installation automatic block system that operated with the alternating current was installed with the Union Pacific Railroad. Since the date, other railroads have made more or less extensive installations. Sophomore signals were used most exclusively up to 1913, when the efficient color light signals was improved to such an extent that there became practical long-range daytime indications. Description: there are two systems of the operating of the automatic block system. General use: the normal clear and normal damage. The normal clear system is the term for the express the normal indication of the signal of the automatic block system, which the indication of the proceed always displayed except when its block is occupied. The normal danger system is the term used to express the normal indication of the signal with the automatic block system, which indication of the proceeding with the given with only with the approach of the train to an unoccupied block. In both systems, the signal assumes that the most restrictive indication of the train enters the block on the track signal, but the train operates with both directions with the same operating with the same condition, with the signals governing the movements of the opposing direction displayed for the most restrictive indication with the specific distant head of the train from one side to the next, depending on the scheme of the signal employed. The signals may be continuously lighted by the oil electric lamps. When the latter are used, they may be approach lighted. Direct current and alternating current are used with the operating with the automatic block system. Direct current is generally obtained with the primary and secondary cells bothly and operates with the track circuit and signal. The signals usually operate with the first voltage of 30 volts or less, with the approximate of 1 volt applied with the track circuit. The alternating current is obtained with the transmission line. Necessary powerhouses, substations, allied equipment is distributed through the signal territory. Transformers are connected with the transmission lines to set the voltage down with the required for the operation signal and track circuit. The direct current track circuit are explained in Chapter 7 for the alternating current track circuits in Chapter 11, sophomore signals in Chapter 12, the light signals of the Chapter 13. Multiple track system. Theoretically, a multiple track signal, but the signal should be spaced with a uniform distance of the part on the level tangent track. With the distance between the compensated with the signal is located with the grades of the curve of the practice. However, it's been possible to maintain desirable arrangement. The various conditions on the road will tend to be very more or less in spacing. The signals of the exact site of the signal is always selected with the care of the consideration being given to such a factor. The approach view of the signal presence of the turn-ins, crossover the side and curve of the grades of the files of the bridge, fills or bridges or tunnels, etc. The automatic block system. Signal for the multiple track railroads generally on the 2-block indication system, although the concern of the 3-block indication signal system has been installed with the road's heavy traffic density whenever necessary to provide with the proper braking distance and some insulation for block indication. 2-block indication. Fixed signal with the 2-block signal system that displays a proceed and approach or stop, then proceed. Indication depending on the block condition. This fixed signal may have 3-position unit or two 2-position units operating with the upper or lower quadrant. The 2-block indication of the system is named for the region with a clear aspect indicates the least of the 2 blocks advanced and such that the signals are occupied with the fixed signal display and approach aspects indicate that only the block immediately in the advanced signal is unoccupied, but the train must be prepared to stop at the next signal. The 2-block indication signals are generally spaced with the braking the distance apart with the minimum of the spacing with the frequently increased with the track vehicle is light. Figure 1 illustrates the aspect displayed with the different signals when the block is occupied with the system 2-block indication signal with only a section of the double track and the signal being normally clear. Alright, normal clear color light signal with direct current neutral track polarized line control. Figure 2 illustrates the circuit with the 2-block indication color light signal illustration double track employed direct current neutral track circuit polarized line circuit. Signal control circuit. The indication displays each signal with the control directly from the polarized line control relay or HER. The control relay of the 29996 polarized line control relay is and follows the positive and negative batteries B and C through the front contacts relay 298.4 for the positive line contact relay when they energize with the relay 2984 line control relay de-energized with the positive and negative battery B and C with the back of the contacts change with the polarity controls of the reverse relay 299.6 with the line positive polarized line control relay. So there's energized reverse by the 298.4 polarized line relay. And control of the relay signal 298.4 singles out the approach with the proceeding indications displayed in signal 299.6 through the contact with the track of the relay 299.6 TR as though the 296 2R TR de-energized signal 2996 must be in restricted position coil with the relay 2996 polarized line control relay. The shunt circuits are provided through the back contents with the track relay 299.6 TR with the shunt for the coil relay the 299.6 polarized line control relay so that the track relay T96 2996 TRD energized with the control battery not only removed from the circuit but the coil of the relay are shunted to the further assure the relay 2996 HGS de-energized. Single lighting circuit. The lighting circuit, the preceding indication signal of the 2996 is followed with the alternating current with the BX10 with the secondary transformer from the front of the. Alright, this shows figure 1 the aspects displayed in the 2-block indication system double track. West and whatever proceeds. This is a aspect in the 2-block tuna going east and west, two lines, 2-block indication double track. Alright, figure 2 shows the BNC battery line for the polarized and the relay contacts of the 6 different gates of the 2 different lines. Circuit of the 2-block indication normal clear 3-position color light single double track using direct current neutral polarized line circuits. Alright, the power transfer of the relay of the POR through the neutral and normal polarized contact relay of the 2996 HGR with the wire 2996 EG with the lamp with the green unit through the filament of the lamp to the wire CX10 through the contact with the relay of the POR secondary transformer should the track circuit 2996 T be occupied with the relay 2996 HGR would be de-energized with the light circuit with the signal with the 29 display with the most restrictive indication followed with the BX10 through the front contact with the relay POR through the back contact relay 2996 HGR wired 2996 ER with the lamp of the red unit through the filament lamp through the contact relay polarized POR through to CX10. The light circuit of the approaching indication of the signal 2996 is followed with the BX10 through the front of the contact with the relay of the POR through the front normal reverse polar contact with the relay 2996 HGR of the lamp the L light through the filament lamp with the front contact with the relay POR or polarized contact relay with the CX10. Should the source for the alternating current fail, the relay with the POR be energized with the same transformer that supplies the alternating current energy for the lamp with the B become de-energized with the changing source for the energy of the lighting for the single lamp with the alternating current furnished with the transformer storage battery furnishing the direct current BX10 and CX10 through the back current contacts of the relay of the POR. Fit the weather. Alright, normal clear Sepmore signal with the direct current polarized traffic circuit control. The figure 3 illustrates with the use of the two black indication Sepmore signal installation double track employing the direct current polarized track circuit. Signal control circuit with the indication displayed in each of the signal with the control directly from the polarized track relay. The control relay of the 3018 TR is followed with the positive negative battery with the primary track battery of the signal 3006. Through the contact with the polar chain with the circuit controller that operated with the signal mechanism closed with the 40 to 90 degrees, the rail with the track circuit 3018T positive battery being on the left hand with the negative battery on the right hand with the coil of the relay 3018TR energized with the normal position at 3006. TR to de-energize the signal of 3006 will display stop and then proceed indication cause of the polarity of the track circuit 3018T to be preserved because of the polar changing circuit with the controller of the signal 3006 when the relay 3018 TR energized with the reverse pole position. The motor circuit with the control of the Sepmore signal is followed the positive battery from the contact with the relay 3018 TR wire 3018 HG mechanism signal with the wire N3018G with the front contact relay 3018 TR with the negative battery. The motor control circuit is thus energized to operate 3018 to proceed to a given approach indication signal at 3006. Display stop and then proceed indication. When the 3018 TR is energized with the circuit, the signal with the 3018 is followed with the positive battery through the neutral contacts relay of 3018 TR wired to the signal mechanism 3018 HG, which will cause the signal of the 3018 display and approach indication positive battery through the future front neutral and normal polar contacts of relay 3018 TR wire 3818 DG the signal mechanism wire number 3018 G2 negative battery causing the signal to display the produce indication. Alright, normal clear light signal with the alternating current tracking control circuit. The figure 4 illustrates the circuit with the use of the two black indication color light with the signal installation of double track electrical robe with the alternating current propulsion installation employed with the double element 2 position central vehicle track relays, the double element 3 position signal and 2 position line relays, and the 110 volt buses with all the locations that have headed and connected from the same source. They were the same instantaneously polarity. Local element circuit. The local element double element relay is connected directly to the BX110 and the CX110 buses with the wire with the HQ and TQ and NX110. The circuit for the local element, the track relay 60TR is followed with the BX110 and through the fuse with the wire to the 60Q TQ through the local element of the relay 60TR with the wire and NX110 to CX110 bus. Alright, single control relay circuits. Line element single control relay, or HR, is energized when the track circuit is advanced with the signal unoccupied. The instantaneously polarity of the line element, the local element, is the same when the signal control relay, repeating relay, or HPR, with the signal advanced with the energized with the opposite when relay HPR with the signal is advanced with the de-energized with the circuit with the line element with the relay A58HR. This follows the secondary transformer of the primary, which is connected with the directed with the BX110 and the CX110 buses through the front and the back of the contact of the relay of the 56 HPR opposite one relay or control repeating relay through the front of the contract relay of the 858TR with the wire 58H through the line element of the relay of the 58HR to the wire 958H the front and back contact of the 56 HPR with the secondary of the transformer. Signal control repeating relay circuit. The signal control repeating relay is energized whenever the signal control relay is energized with the slow acting feature for the causing the front of the contact relay to remain closed with the preventing of the red lamp of the light while the relay HR changes from the one energized position to the other. The control circuit of the relay 60 HPR is followed from the BX110 with the wire 60 HP1 through the contact relay of 60 HR closed with either the energized position of the coil relay 60H PR with an annex 110 with the XX to CX 110 PM busing signal light system. Filament of each light is controlled directly with the secondary transformer located in the single unit of the primary, but the transformers are connected through the relay contacts of to the BX110 and the CX110 bus. Whenever the relay is de-energized with the HPR, the de-energized with the transformer, the red lamp energized through the train approach with the signal with which each relay HPR is energized with the transformer. The yellow light with the green lamp will be energized. Alright, figure 3 shows the two block indication normal clear 3 position sophomore signal double track. Use direct polarized track current. Figure 4 shows the 2 block indication normal clear color light signal double track alternating current track control circuits. Or depending on the position of the relay HR in order to have the marker of the lamp of the burning at any time of the lamp of the bearing of the transformer with the marker light is energized whenever the relay HPR is de-energized whenever the train is approaching the signal. The trigger of the red lamp of the signal F56H is as follows: the BX110 with the wire H56GE4 through the back contact with the relay 56HPR through the back of the contact relay 58TR with the wire 56GE3 through the back of the contact relay 56HPR with the wire 56RE1 to the transformer with the red lamp of the wire with the NX110 with the CX110 with the circle with the yellow of the green lamp with the signal 56 as followed with the BX110 with the wire with the 56G4 through the back of the contact relay 58TR with the wire 56GE3 through the fire front with the contact with the relay with the 56HBR with the wire 56GE2 either with the normal polar contact with the relay 56HR wire 56GE1 with the transformer with the green lamp with the wire NX110 to the CX110 busted through the reverse polar contact relay with the 56HR wire 56YE1 with the transformer yellow light with the wire NX110 with the CX110 bus with the circuit with the marker lamp signal with the 56 is followed with the BX110 wire with the 56ME through the back contact relay of the 58TR through the back contact relay of the 56HBR with the wire 56ME1 with the transformer marker lamp with the wire NX110 with the CX110 bus. The fuses are different location circuits to protect the apparatus shown in figure 4. Alright, we're going to cut this tape at the 3 block indication system.